Hello everybody, my name is Sionna RT. Today I want to explain the data-driven deployment of the configurable intelligent surfaces in cellular networks. Specifically, we developed this framework for deploying RIS in the outdoor urban area. You can find this code in the GitHub address Telefonica Scientific Research, specifically DDRD. And today I will explain for you how is the structure and how we can execute the code that you can use it for the future research and also extending this framework. So this code includes different classes. The main thing is that it has a main script that it is calling different classes and functions, and you can initialize the parameters and execute the code based on this. So it is kind of controller of the whole the code. The second one is a coverage map that is connected to Sionna ray tracing for the computing the coverage map of whole the urban area that you are considering. The third one, the third script, is the outdoor discrimination. This framework is just focusing on extending the coverage for outdoor users, so you need to discriminate outdoor and indoor users. So this framework, this script can do it for you. There are several other scripts like clustering that we applied the beach algorithm clustering for grouping the outdoor outage users, and then for each cluster we are going to deploy one RIS to support all the users of a specific cluster. We have post-processing that is for the filtering, sorting, and simulation data across various stages of the pipelines. We have RayInfo script. It is interfacing with Sionna RT to generate the race between the specific base stations and target points. This ray info, you can find different ray types. You can generate the ray tracing and extracting the ray information, like the interaction between the rays between the different buildings, objects, also the phases, the delays, and the reflection locations, and all the rest of the information. The important thing is that we develop the reflection based algorithm in reflection algorithm data scripts. So it includes two specific algorithms. It calls strongest ray selection and all ray. So this framework includes specifically two main algorithms. One is a reflection-based algorithm, and the second one is a scattering-based algorithm. Each of them you can, if you use optionally each of them, you can deploy the risk optimizing the location of resources, the phase shifts, the base station beamforming, and the orientation of recess. So specifically in this script that I explained, the reflection algorithm data, we developed the algorithm of the reflection base that includes again two algorithms, ray selection and all ray. The next script is the risk orientation. It makes sure that the RIS is going to deploy in proper orientation parallel of the target wall of a building. And then we have another important script, which is RIS reassociation. So some users can, some outage users still can be not supported from the existing RIS or with the assigned RIS, so we can reassign them to another existing RIS to get help from the surrounding RISs, deployed RISs, and we can extend those coverage without adding any extra resource. So this risk reassociation script is doing this job for us. The rest, the scattering algorithm, data scattering algorithm, together they are providing the scattering based algorithm, and that optionally you can use this algorithm. It is faster, but definitely you need a very good computer specification, because it needs more memory. Another code, the final, is the plotting, that it provided some functions for developing or for the plotting the results, such as the algorithm gains, CDF bar, and scattering plots for different scenarios. So now I want to explain that how you can execute this code and this framework step by step. So basically you can find the requirements, the each version of the library that you need to install in the requirements.txt, that probably you can execute the code without having any errors. So the code, as I told you, is the controller of this framework is main.py script, and then you can call different classes and functions and execute the code. So the first one is deploying base station locations and area of interest. So you can configure the base station user location, the base station tilt, orientation, and also by reading the CSV file, if you have some specific location or real world location of the base station, you can deploy them, or you can also adding manually the base station locations and the tilt and orientation in this framework in the at the beginning of the main. So if you make the true, the use a real dataset, you can read the dataset of the base station if you have the dataset, and deploy the base station. If you make it false, you need to manually add the base station location and other parameters. The second one, it is the outdoor indoor user detection. So how it is working? First of all, you need to run the Sionna ray tracing to calculate and compute the coverage map of the whole considered city. So basically, after you computing, you need to make it the false. So for the saving the memory, each when you perform the simulation in each step, it would be saved the result, and for the next step you can read the result and do sequentially step by step for the saving and the memory. Otherwise you cannot run all together, because you get error of the lack of the memory. So then the outdoor discrimination includes two parts, phase 1 and phase 2. The phase 1 is based on the RSRP. So if you one user gets minus infinity from all the base station, it means that it can be indoor. And the second phase is based on the geographical places. By reading the each building locations, it can detect the outdoor and indoor. The third one is after understanding which users are in the outdoor and are in the outage by a specific threshold, you need to cluster them with a specific hyperparameter, that is T. All this information are in the paper with the same name of the that I explained to you, which is the paper name is Data-Driven Deployment of the Reconfigurable Intelligent Surfaces in Cellular Network, that will be published in the Journal of Selected Area in Communication, IEEE. You can find all the detailed information that why we chose some specific hyperparameters with a specific value over there. So this part is using class birch-based clustering. You need to make it true to do the clustering, and then for the next step you need to make it false, because already all the result is saved and you can read the results for the next step. The next step is deploying the reflection-based risk deployment. It is running strongest ray risk location, the precoder optimization, phase shift, and the second algorithm of the reflection base is always risk location, that you need to run all of them step by step. So basically you need to run first Sionna path generation and then make it false, and for the strongest ray you can read the result from the previous step, the Sionna path generation, and you can make it true and do the simulation and go to the next step. So it is sequentially. And then for the fifth step is reclustering and redeployment. So the remained uh, uncovered outage users, we need to recluster them, and also redeployment of the recess. So this section is doing this, and so by reclustering we can reapply some recess and adding recess to the scene to make sure that the uncover unsupported users can be supported with the new recess. The sixth one is risk reassociation. Okay, already we have applied and added some recess the entire the considered city, but still it is possible that some of the users, outage users, are not supported by assigned recess. So by reassigning the res to the specific users or reassociation, we can get improvement for the outage users and also extend the coverages. The last part is the scattering based algorithm, and if you want to go instead of the reflection based algorithm, you can choose the scattering based algorithm and run this part of the code to do again the optimization of the risk and the risk placement, base station beam optimization, phase shift of the risk, and risk orientation, and all of these again sequentially should be executed. Thank you so much. For further information, or if you have any question, you can contact me. This was a quick but complete tour of the DDRD repository. I invite you to clone it, explore the modules, and adapt the pipeline to your own research.